Hi everyone, welcome back. In the previous session, we tried to understand the comparison between CSV, JSON, and Apache Parquet file formats. From this session, we are going to start understanding about the basic concepts of PySpark, and also we are going to discuss about some syntaxes and the built-in functions available in PySpark. And we'll also do some coding exercises as part of this PySpark implementation. So initially, let's try to understand the evolution of various Spark APIs. Firstly, we used to have something called as RDDs, which are nothing but resilient distributed data sets. So whatever the data that we would like to transform, we usually read the data into an RDD, and we used to apply some sort of transformations, such as selecting a few columns out of huge set of columns or filtering the data by using some built-in functions like map and filter. And the resultant output is nothing but again an RDD. So that was the initial implementation and how we used to transform the data using Spark. But with the evolution of latest versions of Spark, we also got two different Spark APIs, which are called as Dataframe API and the Dataset API. Dataset API is mainly used using Scala and Java, whereas the Dataframe API is basically used with Python and R programming languages. Let's say if you're writing your Spark application using Python programming language or R programming language, then basically you are using a Dataframe API. Whereas if you're writing your Spark application using Scala or Java, you're using a dataset API. To understand at a higher level, a data frame in Spark is nothing but the distributed collection of data organized into rows and columns, where each column in a data frame has a specific name and a particular data type associated with it. So basically, if we understand in a simple terms, data frames are pretty much similar to traditional tables in an SQL database, which are basically structured, and every table has column names and associated data types in its column name. And the data sets also obey the same rules, but it has some type safety involved along with it. So PySpark is the Python's API for Apache Spark, which means if you're trying to write a Spark application using Python programming language, it's called PySpark application. It enables you to perform real-time large-scale data processing in a distributed environment using Python. It also provides a PySpark shell for interactively analyzing your data. PySpark combines Python's learning ability and ease of use with the power of Apache Spark to enable processing and analysis of data at any size for everyone familiar with Python. So if you have worked with Python, then you might have known that Python is basically designed to run in a single machine. Even Java or Scala, any programming language that you're trying to write a program, is basically designed to run in a single computer. But the main agenda of Spark is to run its programs or code that was submitted to Spark Engine in a distributed manner so that the Spark Engine will automatically coordinate the work across various computers. PySpark supports all of Spark's features such as Spark SQL, data frames, structured streaming, machine learning, and Spark Core. So as we know, Spark comes with various built-in features, including batch data processing, stream data processing, machine learning abilities, and graph data processing as well. So all the same features are also accessible to write in PySpark as well, which means we can write different skills of applications related to data engineering and data science without learning multiple technologies. The main difference between a traditional Hadoop technology versus Spark is that if you go to a Hadoop technology, if you want to write SQL-like queries, you have to learn Apache Hive. If you want to write Java or Java-like programming language-based programs, then you'll have to go for MapReduce or some other framework in Hadoop. Or let's say if you have a machine learning application which you would like to build using Hadoop ecosystem, then you have a particular framework called Mahout, which takes another set of programming languages to learn. So if a particular company or a client wants you to develop a big data application which involves different domains, and if you are using Hadoop, then it will take a lot of time to understand the technology and build the applications. Whereas if you come to Spark, you can learn only one programming language, but you can implement different applications in different domains since its features are very much generic and it is very much easier for us to understand and easily implement a Spark application when compared with any other big data technology using any other big data technology framework. And we have these 5 different language APIs that are available for us in Spark. And the Spark itself is developed using Scala programming language. So we can use Scala or we can use Java. And we also have language APIs for writing Spark applications using Python, SQL, and R. And as part of these course sessions, we will only concentrate on Python and SQL. And if you already have worked with Python, maybe some of you might have knowledge about pandas. So pandas is basically a library in Python using which we can do data analysis, data cleaning, data pre-processing before we do some sort of machine learning model. And pandas is designed to run only in a single machine. And if you want to adapt that particular piece of code that you have written in Pandas in Spark, we have an extension or we have an API using which we can get the same piece of Pandas code and run the same thing in Spark. So we need not change too much of code in order to run the same Pandas application. So Pandas API on Spark allows us to scale our Pandas workload to any size by running it across distributed cluster of nodes. And there is this reference link where we have clear-cut information about how to implement an existing Pandas code in a Spark environment, or if you want to freshly get started with writing Pandas code within Apache Spark, then you have the code samples in that reference link as well. You can refer to that if you want that. And within PySpark, we have different classes. So there is a module called PySpark.SQL within which there are different classes that are implemented, which internally contain different methods. So we can make use of each of those methods in individual classes to do various data transformations as per our business logic. We will try to go through a couple of them in this session. We have already tried to understand how to create a Spark session. So if you have keenly seen the code of creating the Spark session variable, first we used to import the Spark session library, sorry, Spark session method from PySpark.SQL or Spark session class. So I have already installed Spark in my Google Colab environment. Now let's try to create a Spark session. If you see, basically I'm importing this particular class before I write the syntax to create the Spark session here. Now, when I execute this piece of code, I'm basically importing the required methods or all the methods inside this class, and I'm basically making use of the Spark session method, and inside that I'm basically making use of all the other objects to create my Spark session variable. And once I have the Spark session created, I'm basically assigning it to a variable named Spark. And once this gets executed, and when we execute the Spark keyword, we will get the information about the version of Spark we are running and the number of executors in the application and everything. And one more thing that we need to understand is that we are running Spark 3.0 in Google Colab, but as of the current day, there is a Spark version of 3.5 that is available, and it has a couple of extra built-in functions that got introduced when compared with the Spark 3.0 version. I'm trying to give a code samples for version 3.5, but I cannot run those in here. But I'll try to show the functions that are available in 3.5 and I'll run them in Databricks Notebook. Now, we have already created a Spark session here, and we can start writing any Spark code from now on. Moving on. We have this class called PySpark.SQL.Dataframe. As we already mentioned that a data frame in PySpark is nothing but a distributed collection of data organized into rows and columns. Now, A data frame can be considered equivalent to a table in an SQL database. And this is a sample example for, sorry. So let's say if we have data in a CSV file, if we want to create a data frame, then we can use this Spark variable and the read method and the CSV function to take the path of the CSV file where it is present and create a data frame. But let's say if you do not have a CSV file, if you are just playing around to create an empty data frame with some random data, then you can always do that by using a list of tuples. We'll try to take a look at this with a code sample in a Google Colab notebook. Let's come here and then start writing some code here. So firstly, let's try to create a syntax. So there is this create data frame method which takes two main arguments. One is the data, which is nothing but the actual data that we would like to have in our data frame. And my data can be in a list of tuples, or it can also be a dictionary. I can actually convert my dictionary into a list of tuples and then create a data frame, or I can directly provide a list of tuples. So this is a list in Python, which is enclosed in square brackets, and the list contains information of my records. So if you execute this, now a data frame will be created, and I can actually view the contents of this data frame by using the show method. Now, the data takes the actual data part, and the schema takes what is the column name that I would like to give to these two set of values or two attributes here. So if you see here, the letter 1 goes into number and the letter P goes into letter column. So this is how we can simply create a data frame, and we can start playing around with this. Let's say if I want to select or select a particular column, then I can use a select or select. I'll say from this data frame, select only this particular column. Sorry, I'll give number. Now this is going to select only that particular column, and it is going to show the result. So this is how we can actually create a simple data frame. Moving on, how to read the data from a CSV file. So let's try to read some sample data. We already have some sample data available here under sample data, and we will try to read data for California housing test.csv file. So let's paste this. Let's execute this. So we have this California housing test. In this file, we have some amount of data, and using Spark variable and the read module and the CSV method, we are basically reading the data in this particular CSV file into a data frame called California DF. Now, if you want to see the contents, you can give data frame name dot show method. Now it is only showing the top 20 records. Let's say if you want to limit the number of results to 10, then you can give 10. If you want to limit to 100, then you can give 100, and it is going to showcase all the 100 results. So it's by default, the default number of records that it shows is 20. And I gave only 2, and it is only showing the top 2 records. Now, moving on, we have various built-in functions within the class called PySpark.SQL.DataFrame, which we can use to do various transformations. So I have also provided a reference link to Spark documentation where you can find various built-in functions that you can operate upon the data frames. So this is the class, and this particular class has different methods, and we are going to see some of them. So starting with columns. So there is this method called columns, which we can use to retrieve all the column names in a particular data frame. So if you take this particular data frame, we have the column names longitude, latitude, housing median, age, total rooms, total bedrooms, population, and all these column names. If I want to print all of them at once, then I can actually use the data frame name dot columns. So it gave me a list of column names. Now, you might be wondering, how can I make use of these column names? Maybe you might want to append, or you might want to parse through this list of column names in a particular scenario. Then you can use a for loop and iterate on these values something like this. Let's say for I in so and so, print I. So you might want to print each and every column name, right? So you can use this particular method when you want to retrieve all the list of column names available in a particular data frame. Moving on, the second function that is available for us is count. So let's take this data frame name and let's try to find out the count of records that are available in this entire data frame. So this particular file has some n number of records, but we are able to see only the top 10 as part of this. And even when we are seeing these, we are only able to see top 20. We do not know definitely about how many number of records are available in this particular file. If you want to find out, we can use a count method. So it says this particular data frame has a count of 3000 records. Now, the third function is print schema. So print schema is going to print out the schema, which is nothing but the column name and the associated data type in a tree format. Let's try to use print schema method. Data frame name dot print schema, which is going to print the result of each and every column name, the data type, and whether it can have null values or not. To understand this in a simple terms, if you take an SQL table, whenever you are creating the DDL of the table, like the creates table statement, you're going to provide table name and then list of column names, where each and every column name will be associated with the associated data type and whether it can have nulls or not, like null, not null, something like that. Similarly, when we are printing the schema, it is telling us the column name and the data type and whether it can have nulls or not. Let's say if you do not want to have null values in a particular column, then you can always make sure that you are inferring the schema on a particular column or attaching a specified set of rules saying that, hey, do not accept null values in this column. So you can always do that. For now, we'll not go to that part. We'll go to that part in the coming sessions. But for now, let's keep it simple and try to understand the basic functions. Moving on, if we want to select a few set of columns, then we can always do that using the select method. So let's try to give data frame name dot select, and in the select method, we can give the column names. Let's select longitude and the latitude. So what we are trying to say is, hey, select only these two columns from this data frame and show the results using the show method. Now this is going to show only those two columns. Let's say if you want to select all the columns, then you can simply put star, which is going to show all the column names, or simply you can remove the entire select and use show method, which is also going to show all the columns. Anything is seen. So if you want to specify a particular set of column names, then you can always use the select method. Now, moving on. If you want to select a particular columns, along with that, if you want to transform the data, let's say, let's try to print one more column. Well, let's print all the columns for time being. Now, let's say you have this column called total bedrooms. Now, you would like to make this particular value double. Let's say if we have 661, you would like to multiply this number by 2. Similarly, you would like to apply every record of this particular column into 2 so that whatever the result, you would like to store that as a resultant value. If that is the case, then you can do that using a select expression. So what happens is that we can actually provide a SQL expression like syntax within the select expression method. What I mean to say is it goes something like this. Now, here in this particular data frame, I'm basically selecting the longitude, and then I'm also selecting the housing median range where I'm trying to find out the absolute value of it, and then the median income into two. So basically, I'm multiplying median income into two, and I would like to show the result of the top five records. When I execute this, basically my result looks something like this: longitude, which is exactly the same, and then absolute value of my column called housing median age. So my housing median age is 27 point something something, and when I ask for the absolute value, it automatically did some typecasting and then it displayed the results. Instead of having these many zeros, I have only one zero. And then my median income. So let's take median income value for this particular thing, and I multiplied this by 2 and it turned out to be 13.2 something. Yeah. So basically I can actually provide a SQL like syntax. Let's say if I would like to divide the longitude by 2, then if you see the results, if you see, it's a new result. So we can always provide SQL like syntax using the select expression method. Moving on, if you want to rename these column names, then you have two different methods. Firstly, let's try to take a look at a simple syntax using SQL-like syntax in renaming the column names. So from the California DF data frame, whatever the result that I got from the absolute value of housing median age, I would like to rename that particular column as housing median age. Like if you see the column name here, it doesn't look good. So if I want to rename this column name, I can simply give as, and I can give my new column name because I'm using the select expression method. So it can accept SQL-like syntax here. And similarly, this column name doesn't look good. So I gave one more, the same column name as the new column name. Now, if I see the result, it is going to give me a intuitive naming convention for individual column names. Now, let's go for the second syntax. Let's say if I'm not using the select expression method, but instead I'm using a select method. So how does the syntax look like? So if I'm using the select method, this is one way of selecting a column name. Instead of giving the column name in quotations, I can also make use of the data frame name inside which the column name is present. So data frame name dot column name, and then I'm basically using the alias method, which is the PySpark method, and I'm giving a new column name. So instead of longitude, I'm giving it as longi, so which is the short form for longitude. Yeah, I can give whatever I want, and it is going to show me the result. So, and also you can always select multiple column names by separating this. And let's say if you want to get this thing, let's say maybe California DF dot latitude, or let's say median age. And if you want to rename this to something like HMA, you can always do that, but you need to make sure that this is in quotes. And yeah, here it is. So if you want to rename a particular column name, if you're using select expression, you can use SQL-like syntax using the as keyword. If not, if you are using Python or PySpark, then you can use alias method that is available in PySpark to rename the column name. And we will discuss these final four functions and we will close the current session. Now, sometimes we would like to create a new column instead of an existing column. Let's say I would like to have all my column names that are available here. Along with these column names, I would like to have a new column where the new column will have the twice the value of median income. Let's say if I want to have a new column saying double median income with double the value of this, then I can use the with column method. So let's try to do that. Let's take the California data frame. and I'll use with column method. And the with column method takes two main arguments. The first argument is the new column name that I would like to have. And the first column name is twice median income and the associated value that it should have. So this is the new column name that is going to be present at the end of my data frame, and the values that it should have will be this. I'll give with syntax like this. Basically, in order to select a particular column, I can always make use of syntax saying the data frame name and the column name in that particular data frame. And I can say, or I can actually give the same dot show. This is going to show me the result with the same values, but a new column name with the same values. But let's say if I would like to do some sort of manipulation like into 2, it is basically doubling the median income from here to here. Now, we have one more function called with columns. So the with columns is nothing but an updated version of with column, where instead of providing a single column for one with column method, I can provide multiple column names. So what I mean to say is, let me give you the syntax. So if you see this particular syntax, basically I'm trying to create two different columns. Like there is this column called housing median age, which I would like to divide it by 2. And I would like to have a new column called half housing median age. And I have one more column called population, which I would like to multiply by 2 and store it in a new column called twice population. And if I and this method is going to create two new columns. So instead of writing with column twice, where each and every time I'll be specifying the specific logic, I can reduce the amount of syntax and write it in a short form using this particular syntax, where I'll have a dictionary inside which I'll provide the key, I mean, the new column name and the logic that need to be used to fill the values in that column as key value pairs. And if you have multiple columns that you would like to add into your data frame, you can separate all those by a comma. And this particular version of with columns is available only from Spark version 3.3. So we are using Spark 3.0, which is why we do not have access to this particular feature. So even if I try to execute this, this is going to throw me an error saying that this particular feature is not available. Like the with columns, I mean, data frame class does not have any method called with columns. So yeah, I'll comment this out. Moving on, with column renamed. So there are times when we would like to create, return a data frame with updated column names. If that is the case, then I can make use of the with column renamed method. So the syntax goes something like this. So the data frame name and the with column rename method. And the first argument that this with column rename method takes is the new column name and what is the column name that I would like to provide. So let's try to execute this and let's try to see the results so that we can easily understand. So we used to have, okay, let's try to compare. Uh, we have this column called housing median age. This is the column, and we renamed this particular column to a new column named median age, which is available here. So basically, we are just renaming a particular column name. And if you are trying to rename a column name within a SQL, within a select method, then you can always do that using the alias method as well. But if you do not want to select a particular column name, but instead just update one particular column name, then you can make use of the with column renamed. So the main difference between renaming a column in the select method versus with column renamed is that when you are using select method and when you provide a particular column name, you're going to select only that particular column and you can only rename that particular column. But let's say if you do not want to touch any columns except one column which you would like to rename, then you can just rename use this method to rename that particular column. Hope this makes sense. And similar to with columns, we have with columns rename method where we can actually rename multiple columns at the same time. So but again, this with columns rename method is only available from Spark 3.4.0, which means we do not have access to this particular feature since we are using Spark 3.0. So hope this makes sense. I'll try to share this particular notebook link uh, as a description in the comments, and you can go through. If you have any questions, please comment, and I'll try to come up with one more session very soon with more built-in functions and more functionalities, and we'll do more practice sessions like these. Thank you guys. Have a good day.